and welcome to this quick how to help video on rationalizing the denominator. Okay, so what that actually is asking us to do is to make sure that we always have a rational number as a denominator when it comes to our fractions. So sometimes when we are working with our surds, we can have a fraction appear in our workings out, or it might be that we've been given a fraction that we have to simplify. If the denominator has a root as part of its answer, then there's more to do. Let me show you what I mean. Okay. If I was to give you the question 12 root 9, so we've got root 12 over 9. Now we know that our rules mean that we could rewrite this like this. We also hopefully spot that that is a square number, which means it will simplify further to 12 over 3. Now my denominator is a rational number. It is not a root, it is not a problem. That is absolutely fantastic, which means I probably think I've finished. Sadly not. With surds, we've always got to look for where we could simplify. And the root 12 does simplify. So we'll do it here just to remind ourselves of how it works. So I'm going to split that into root 4 times root 3. The 4 is the square number. Remember, I'm always splitting, so there's a square number in the pair. That way it gets me an integer, and that is now my simplified version, 2 root 3. So I've got 2 root 3 over 3 as my final answer, and that would be the perfect answer. Okay. But if I gave you this one, 25 over 31, we can go through that same process. My square number is here, which is helpful. Square root of 25 is 5. And that is what I've got left once I've simplified that one. I'm looking at the root 31. I'm asking myself, will that simplify any further? It's a prime number, so it isn't going to simplify any further. So that's it. It's in its simplest form as root 31. However, as an answer, that's not acceptable. We don't leave the denominator with an irrational number. So I've got to come up with something now that's going to get rid of that root. It's going to cancel it out and make it disappear. Okay, and this is what we're going to do. So we learned this in the very first video. We learned that when we multiply a root by itself, we get this cancelling. Yeah, root 5 squared means the inverse of the square and the root cancels out, and we're left with a whole number. So I can do exactly this to get rid of that root 31. I can multiply by root 31. And when I multiply it to that, it's going to get rid of it and just give me 31 on the bottom. So that's great. That's a rational number. But I remember I'm working with a fraction and I need to keep my fraction equivalent. To keep my fraction equivalent, whatever I do to the bottom, I must do to the top. And so I've now, if you like, transferred the root to the numerator. Okay, that's acceptable. That's okay. We're allowed roots as numerators. We just don't want to see them as denominators. So multiplying through by the same surd, by the same root, is going to cancel that root sign out and leave us the integer that's just tucked inside it. Okay, let's look at another one. Okay, so I'm going to give us, let's say we've done a piece of maths and we've ended up with this result. Okay, so we've got 32 over root 40. Okay. Now, straight away, I'm looking at that and I'm thinking, okay, that's a root on the denominator, can't have that, gonna have to sort it out. So I could go straight into multiplying to give me 32 root 40 on the top and just 40 on the bottom. Okay, now there's a lot of simplifying that can now go on. The root 40, if I just consider that to start off with, that's going to split into root 4 and root 10, which is 2 root 10 is a final answer. So let's show that over here. So I've now got 32 times 2 root 10 all over 40. And then I can start cancelling. I can start making this smaller. I could cancel at that point, or I could go straight into getting my 64 over 40. Sorry, let's get that big enough. And now it's squashed up to that root 10. And then I can start cancelling my numerator with my denominator, just how I would cancel normal fractions. And if I did that, I would end up with 8 root 10 over 5. Okay, 8s into 64 go 8, 8s into 40 go 5, and that root 10 just stays with the number at the top. So that was one that might be a little bit trickier. Again, you just got to keep saying, have I finished? Is there more I can do? Is there a square number in that root that I can find? And so on. Okay, I'm going to show you a particularly tricky one now. So this is taking us up a whole level and some probably. Okay, so we're going to, what should we do? Let's do 4 plus 5 root 5 all over root 5. Okay. Now, I know what I need to do to get rid of the denominator. I just need to times through by root 5. Got to do it to the top and the bottom. And the denominator is nice and simple. The numerator is going to take a little bit of work. I've got to be considering that the numerator is 4 plus 5 root 5. And I want all of that multiplied by my root 5. So whenever I've got quite a lot that I need to make sure I multiply, I bracket it. When I want to do all of something, I use that all of to be my signal to put brackets in. And then I'm going to expand my brackets. So root 5 times 4 is 4 root 5. And then we've got root 5 times 5 root 5. Now, root 5 times 5 root 5. I'm writing it down because I want to see it. If I see it, if the information is fed to my brain, it's going to help my brain work it out better. I've got an integer, so I'm going to bring that out. So I've got 5 times root 5 times root 5. Obviously, I've got this double thing happening here, which means that's going to cancel to 5. And then 5 times 5 is 25. So I've got 4 root 5 plus 25 all over 5. Okay, so let's just clean up a little bit of this. Now it's standard to write any whole numbers first. So if I wanted to make this look and and fit with our sort of standard notation better, I would put my 25 in first, and then put the positive 4 root 5 in second. That's all over 5. Now, this is where you have to be really, really careful, because in my previous example, I was cancelling the fraction top and bottom, wasn't I? And I got it eventually to 8 over 5, I seem to remember. So it's really tempting to want to start going, 5's into 25, go 5, I can get rid of this. But I can't actually apply that to this style of question. In the other question, everything along the top was multiplied. So a multiply and a divide cancels out, which is why that's okay. But because I've got an add here, it stops me from doing it. Divide and add are not the inverse of each other. And I think that's the easiest way to try and remember it. Otherwise, you can get bogged down and you can overcomplicate it in your brain. So if you had, what did we have? We had 64 root 10 over 40, didn't we? So in this example, there's no plus, there's no minus, there is a times happening here, but there's no plus or minus, which means I can go into my fraction rules and cancel. This here, I've got to think of this as stopping me in my tracks. I can't divide. And I think the easiest way to remember is to just think it's not the inverse of each other. So I can't do that. Okay. So that was one that was a little bit trickier. We're going to just do one more. I mean, there's loads of different ways they can give these questions. So there's loads of examples. I could go on and on forever, but we just want to get that principal idea with a quick how-to video, don't we? I did want to show you this one, so we won't go crazy. But if I had 3 plus root 2 on the bottom, then I've got a little bit more going on, and I'm going to have to do more than just multiply through by the root 2. So what I do with this is I use the difference of 2 squares to completely cancel out the root on the bottom, okay? So I'm going to multiply by 3 minus root 2. And I'm obviously going to do that to the top and the bottom. So let's just see this in action. If I've got 3 plus root 2, and I multiply it with 3 minus root 2, and I do my crab's claw, 3 3s are 9. I've got minus 3 root 2. I've got plus 3 root 2. And then I've got a positive and a minus. So it's minus, the root cancels, and I've got 2. This center bit, because I did a plus and a minus here, I end up with a plus and a minus here. They cancel each other out. If I've got 3 root 2s, and then I take 3 root 2s away, I have no root 2s left. So they are completely gone, which is what we want, because we don't want a root in the bottom of our fraction. I've got 9 here, take 2 here, I've got 7. So the denominator is 7. Now I've got to consider the numerator. I've got 3 already there, and I want to times by all of 3 minus root 2. So I will stick that in a bracket so that I make sure I do everything properly. 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2. So I've got 9 minus 3 root 2. And again, think, I've got a subtraction there. That puts the brakes on. There's no more cancelling. I can't be dividing top and bottom. All right. As I say, there's tons of different types of questions, but just that main principle and those main techniques for getting rid of those roots are what you want to be doing. All right, so I hope you found this useful. If you are finding the videos helpful, then please subscribe. That's always good as well. And then when I'm adding new videos, you get to see them almost straight away. All right, thanks for joining me.